Now that we've learned how to add and subtract integers, it's all seeming fairly simple. At least that is when it's all one type of problem. It starts getting a little bit trickier when we mix up the addition and the subtraction. So part of what your homework and job for the day is to make sure that you can sort out and apply the appropriate procedures for given problems. Let's just review quickly. When I'm adding, it's really, if you think back to the checkers, if I've got a negative and I'm adding in more negatives, think red checkers and red checkers, I've got all red checkers and I just add them up. The same thing would be true if I'm adding all black or positive numbers. Okay, so we said that these were like signs, add. And of course, we don't have to worry about what sign there is. It is use the sign of the winner or the greater because all the signs are the same. So when I'm adding negatives together, I get negatives. Then if I think about the other, if I'm adding unlike signs, remember our checkers, they battle, and 3 positives take out 3 of these negatives, leaving -3. Or, the same token, if I had +6 plus -3, I still have unlike signs, and 3 of these negatives take on 3 of these positives, but it ends up positive. So I have unlike signs, subtract, and we use the sign of the winner, or now that we know the term, we use the sign of the greater absolute value. Greater absolute value. In other words, -6 has a bigger absolute value than +3 because the absolute value of -6 is +6. +6 has an absolute value that's greater than -3 because the absolute value of +6 is 6 and the absolute value of -3 is 3. But I will, just to be clear, value, I'm just going to remind you that that means the winner, the one with more. Then yesterday we talked about subtraction being the same as adding the opposite. So if I want to add -5, I'm going to say -5 minus 2. That's the same as adding the opposite. And then I follow my rules for addition. So that's just a recap of what we know. When you have a mixed problem set, the first thing you need to ask yourself is, what operation is it? And if it's addition, just follow the rules, like sign, add. If it's subtraction, well, actually, let me go back here and and just say, okay, my eraser isn't working. Don't know why. I want to make it clear here. One of the mistakes that people make, the changing the signs. Don't change any signs. The whole reason for changing the signs in subtraction problems is to make it an addition problem so that we can follow the rules. Okay? If it's subtraction, remember that subtraction is the same as adding the opposite. So change to an addition problem, an equivalent. Addition problem. Remember though, think about the checkers. Never change the sign of the starting number. Think of it as the checkers. If I want to say 5 minus 8. I'm starting with the number 5. If I change that, it's a completely different problem. If I've got 5 checkers, this is the same as adding the opposite. I'm going to end up with -3. I have to change, don't change this sign ever. Never. Always change the sign of subtraction and make it the opposite of the problem you're dealing with. Always in 7th grade math, or almost always, everything we learn gets applied to algebra. So we learned in the last unit how to combine like terms. This is no different than what we're going to be doing now that we are also using negative numbers. Example, if I have 3x minus 5 plus 6x minus 8 minus 5x. I'm going to be combining all of these like terms. In the beginning, you probably want to change all of the subtraction to adding the opposite, adding the opposite, adding the opposite. Then you group the like terms, starting with the variables. 3x. Notice I'm including a box around the sign in front of the number. Okay, so I have +3, +6, those two give me 9, and -5, so that gives me 4x. When I combine -5 and -8, I get -13. You could also call this 4x plus -13. 4x minus 13, 4x -13. And we know that these are equivalent expressions because subtraction is always the same as adding the opposite. Usually, in texts, they will show the answer as being -13. That's kind of the only thing you really need to get used to. So let's say if I have 8x plus 4 minus 13x minus, 9. What I need to do first is say subtraction is the same as adding the opposite. Then I group my like terms. +8x and -13x is -5x. +4 and -9 is -5. Again, this is the way they will write it, as if it's -9, that's the same as minus, if it's -5, that's the same as -5. But if in the beginning, when you're getting used to this, you want to call it plus -5, it's all the same. The one final thing are word problems that have positive and negative numbers. So I think just some things that come up on this sheet that you might not know about. If I write a check for, $15, what happens is that $15 comes out of my account. So the 15 would be like a negative number. If I am talking about how old I am, okay, and also the other thing on this sheet is they talk about BC, the years BC, and AD. BC, in our day it was called before Christ, but I forget what the more appropriate, politically correct way to say it is. But these are negative numbers, and these are positive numbers. So if somebody was born in 9 BC, that's like saying 9, -9. And they lived until 25, the year. They died in the year 25. Well, the way you figure out how old someone is you say the year they died minus the year they were born, and you do the math, and you can see that this person was 34 years old. Think about that. You know what year you were born. You know how old are you now? So I forget what year you guys would have been born in. Let me think. Probably about 2003. So if you were born in 2003, and it is now 2014, then you are 11 years old. I guess most of you, a lot of you are turning 12. But anyway, you get the idea. On word problems, the important thing is to translate the words into math.